And then our first capillary bed is going to make these veins, which are portal veins. So those portal veins are going to be carrying releasing factors. Now notice where those portal veins end up. They form another capillary bed, which is in the anterior pituitary gland, not the posterior pituitary. So this is the anterior pituitary gland. So what is it going to deliver? It's going to deliver the releasing factors. And it's going to take up anterior pituitary gland hormones. So it's going to deliver these releasing factors. And it's going to pick up the hormones. Such as prolactin and luteinizing hormone and FSH and TSH and so on. And then these are transported to the body via the hypophyseal veins. So we'll go over this again more thoroughly after break, but let's, just to review before we look at the posterior pituitary, for an example, again, the thyroid gland. Right? So let's say that, well, the thyroid gets a little complicated. Let's look at the ovaries. And let's say that estrogen levels are low, right? So blood coming in the superior hypophyseal artery to the hypothalamus are going to have low levels of estrogen. So not very much estrogen is going to leave and go into the hypothalamus. With low levels of estrogen, the hypothalamus is going to make releasing factors called gonadotropic releasing hormone. So higher levels of gonadotropic releasing hormone is going to go into the blood here and be carried down the portal vein and leave in the pituitary through cap bed 2. Those high levels of gonadotropic releasing hormone are now going to cause the anterior pituitary gland to make more FSH and LH. Okay. And so let's look at the adrenal gland, which makes cortisol. Cortisol is a stress hormone. Okay. It also makes aldosterone, which is a salt-regulating hormone. So let's say you have low levels of cortisol, lower than you should. Coming into the superior hypophyseal artery, leaving cap bed 1 are going to be low levels of cortisol. Hypothalamus is going to increase secretion of adrenal cortical releasing factors or hormone, which goes down the portal vein, leaves cap bed 2, causes the anterior pituitary to make more ACTH, adrenal corticotropic hormone, that goes back into cat bed 2, goes through the veins, to the heart, to the adrenal glands, and it makes more cortisol. Okay? So what we're saving is this doesn't have to go to the heart and back again to deliver those releasing factor chemicals, hormones from the hypothalamus to the pituitary. We save one round trip. So cat bed 1 delivers systemic hormones, picks up the releasing factors. Cat bed 2 delivers the releasing factors and picks up the anterior pituitary hormones. After break, we'll follow that a little bit more and look at this release cycle. Okay, before break though, what about posterior pituitary? Does it get releasing factors from the hypothalamus?
Yes.
We look at this. Notice the portal vein system completely avoids and doesn't go to posterior pituitary. So it gets its own artery supply of oxygen and nutrients and so on from the heart via the inferior hypophyseal artery. Delivers its 2 hormones, if they're required, the ADH and oxytocin, and then they go out their own hypophyseal veins. Why don't releasing factors or hormones get to the posterior pituitary? Is this the site of synthesis?
No.
No, it's back up here. Okay? So the only thing we find in the pituitary stalk associated with the posterior pituitary are the nerve fibers, the axons, that are transporting the actual hormones. Okay? So there's 2 patterns of synthesis and 2 mechanisms of regulation. So if there is a regulation of what these make, it comes from the bloodstream up here. The bloodstream down here is merely picking it up. It's not the site of any kind of regulation. Okay? All right, let's take a break till 9, and then we'll do some more comparisons looking at this negative feedback cycle. Okay, what happens if the level of one hormone is low and another hormone is high? So 9 o'clock.